Let's start with a definition. We're going to define what it means for two sets to be disjoint. Two sets are disjoint if and only if they have no elements in common. So A and B are disjoint if and only if, when I take their intersection, I get the empty set. They have nothing in common. Let's look at an example. Let's say A is going to be the set 1, 3, 5, and B is going to be the set 2, 4, 6, and I want to know, are A and B disjoint? Well, I can look and I can see that they have no elements in common, so my answer is yes. And really, you just inspect these. You visually see that they have nothing in common, so you would say yes by inspection. A and B have no elements in common. Okay, so now that we know what it means for two sets to be disjoint, let's talk about what it means to be mutually disjoint. So now we could have more than two sets. The sets A1, A2, A3, however many sets you want, are mutually disjoint if and only if no two sets AI and AJ with distinct subscripts have any elements in common. So what this means is AI intersect AJ. This intersection is the empty set whenever the subscripts are not equal. I is not equal to J. So again, we want to look at an example here. Let's say I'm going to have three sets. So A1 is going to be the set 3, 5. A2 is going to be the set 1, 4, 6. And A3 is going to be the set 2. And I want to know, are A1, A2, and A3 mutually disjoint? So we have to take each pair and compare them and see, do they have any elements in common? So let's start with A1 and A2. You're going to do inspection and see they don't have any, they have no elements in common. And you're going to repeat this. Now take A1 and A3. Do they have any elements in common? No, have no elements in common. And then finally compare A2 and A3. So look at set A2 and A3. They don't have anything in common either, have no elements in common. Again, by inspection, so my answer is yes. These sets are mutually disjoint. So yes, A1, A2, and A3 are mutually disjoint. All right, let's look at one more of these. B, let's say B1 is 2, 4, and 6. B2 is 3 and 7. And B3 will be 4 and 5. And I want to know, are these sets, are B1, B2, and B3 mutually disjoint? So let's look. And my answer here, if I look at B1 and B3, they have something in common. So the answer is no. B1 and B3 both contain 4. All right, so now that we know what mutually disjoint are, what that means, let's talk about a partition. So definition: a finite or infinite collection of non-empty sets A1, A2, A3 is a partition of a set A if and only if two things have to happen. So the first one is that A is the union of all the AI, and 2 is the sets A1, A2, A3 are mutually disjoint. So again, we came across a definition. Let's look at an example of it. Let's say my set A is the integers from 1 up to 6. And I'm going to take A1 to be 1, 2. A2 will be 3, 4, and 6. And A3 will be 5. And so let's look what happens when I take the union of all these sets together. You combine them into a single list, 3, 4, 5, 6. So when I take the union of them, I get A back. So I meet the first condition. And if I look at these sets and look at each pair, A1 and A2, I look at A2 and A3 and A1 and A3, they don't have anything in common. So I can visually see A1, A2, and A3 are mutually disjoint. So my answer here is that yes, A1, A2, A3 is a partition of A. Now it needs to satisfy both of those conditions. If it fails either one, then it would not be a partition.